All right, guys, I'm back. Let's go ahead and get started on lesson 81. So, lesson 81, solving inequalities with variables on both sides. So, if you haven't already, make sure you open up your book to page 532. And we're going to start with the warm-up. Okay, so follow along by taking some notes as I'm going. Pause, rewind, fast forward, whatever you need to do so you can make the best out of the situation. Okay, so we're starting with warm-up numbers 1 through 5. So go ahead and pause the video because I'm about to start doing the answers here. So pause so you can go through them on your own. Okay, so number 1. Number 1 says an equation or inequality that is always true is called a what? It is called a identity. Identity. Okay, and then number 2, so we're going to solve for each inequality. Okay, so our first one is 6x is less than or equal to 42. Okay, so how would we solve for that? Well, we're going to divide, we're going to get x by itself. So we're going to divide both sides by 6. That leaves us with x is less than or equal to 7. Okay, and then we have, let's see, number 3. Number 3 says -3/4 is greater than 5/8. Whoops. -3k over 4 is greater than 5/8. Okay, this one's a little bit more challenging. So first off, we're going to multiply by 8 on both sides. And that gets rid of our 8 in the numerator and denominator, because remember, 8 equals 8 over 1, and then 5 times 8 is going to be 40, divided by 8, that's just going to be 5, okay? So, but when we do it on this side, we have 8 on top and 4 in our denominator. So with that 8, one thing we can do is simplify. So 8 and 4, the 4 would turn into a 1, and our 8 turns into a 2, because 8 divided by 4 equals 2. Makes it kind of easy for you. So we are left with 2 times -3k is greater than 5. And then we'll do seed here. We have 2 times -3, which is going to be -6k is greater than 5. Okay. Then our last step to get k by itself is divide by -6 to both sides. But remember, when we divide by a negative, that's going to flip our sign. So when we do that, we are going to have k is less than -5/6. That's going to be our answer for number 3. Okay, so I'm going to get my eraser out here. Get rid of all this stuff. Oh, there we go. And then for number 4, we have 2p plus 3 is less than -25. And the last few of these guys here. Okay. So number 4. we have 2p plus 3 is less than negative 25. I'm going to change colors this time. Okay, do green. Okay, so right now we're going to do seed. That's always the first step that we're going to do with these type of problems. So first off, I'm going to subtract by 3 on both sides. So I'm trying to get that p by itself. But that addition sign right there is going to, so the opposite of addition is subtraction. So subtract by 3 to both sides. We are left with 2p is less than negative 28, right? Because negative 25 minus 3 is going to be a negative 28. Then divide by 2 to both sides to get that p by itself. You are left with p is less than negative 14. So the only time that our sign flips, like in number 3, if you need to go ahead and rewind to that example, is when you divide by a negative number. Not if you have a negative answer, if you're dividing by a negative number. So if our 2 here was a negative 2, so if we had a negative 2, we had to subtract by negative 2 to both sides, then that would flip our sign and we would have a completely different answer. So we would have p is greater than positive 14. P is greater than positive 14. So that negative sign flips your answer. And yeah, okay. So let's do number 5 as our last one here. Number 5, last warm-up problem. So we have 5x minus 3, oh boy, minus 7x is less than or equal to negative 9. It's a negative 9 there. Okay, so this is pretty much the same problem as number 4. The only difference is now we have a couple, just one extra step that we have to do. So first off, again, we're going to do seed. So trying to get that x by itself. This time, let's use orange. So add 3 to both sides. Add 3 to both sides. We are left with 5x minus 7x, because that's 7 is a negative, has a negative in front of it, and then less than or equal to negative 6, because we are adding 3 to that negative 9, right? Okay, so now we have to add like terms. So we have 5x minus 7x is going to be negative 2x is less than or equal to negative 6. Divide by negative 2 to both sides. This is where it gets a little, we have that sign flip because we're dividing by a negative number. We are left with x is now greater than or equal to positive 3. That's our answer. So that's where we have the sign flip there. If you need to, go ahead and rewatch some of those examples if you need any extra help. It also says right underneath the number. So like number 1, if you're having problems on that, it is in lesson 28. Number 2 is in lesson 70. 3 was also in lesson 70. And then 4 and 5 were in lesson 77. Okay, so once you get those all done, now we're going to move on to example 1. We have some new concepts, so I'm going to get my board all cleared off, so I'm going to pause real quick. Okay, guys, example number 1. So I'm just going to do letter A. You can also do letter B once we are done with letter A. So let's start with letter A and get going on this. So this is very similar to our warm-up problems. except now the only difference is we have an inequality on both sides. So we have x on both. Spotlight here. We have a 2x on the left side of our equation, and then we have a negative 5x on this side of our equation. Okay, so we are adding like terms here. So either way, you can do this. You can subtract 2x to both sides, or you could add by 5x to both sides. Me personally, I would rather do the adding 5x to both sides because I like positive numbers better. So that's what I'm going to do. You can do either way here. Use this bluish color. So plus 5x to both sides, plus 5x. And so what's that do? That cancels out our 5x to the right side of our equation. And then over here, we have 7x plus 7 is greater than positive 21. So now we have to add like terms again. So subtract by 7 to both sides. If we were dividing by negative 7, then we would switch our sign. But since we are subtracting, we don't flip the sign. It's only when you're dividing or multiplying by a negative number. So we have 7x, our 7s cancel there. It's greater than 14 because 21 minus 7 is 14. And here we go, divide by 7 to both sides. We have x is still greater than 2. Okay. So if we were to divide by a negative 7 to both sides, like I said just a second ago, that is when we would flip our sign. But since we didn't divide by a negative number, we did not have to flip our sign. So go ahead and do letter B now in your notes. And I'm going to start with example number 2. So I'll give you guys a sec to get started on that. Guys, so example 2, simplifying each side before solving. So this one's not too bad. If you understood example 1, then you shouldn't have any problem with example 2. So what we have here is we have 2 times x minus 8 minus 3x, which is greater than 6 minus 3 times 2x plus 4, close parentheses. Okie dokie. So what are we going to do here? Well, just as it says in the title of the example, we're going to simplify each side before solving. So what does that mean? We are going to do seed yet again. So first off, we're going to take 2 times the x here. We're going to get 2x. And then you'll take 2 times negative 8, and you're going to get negative 16 minus 3x is greater than 6 minus, so now we're going to take 3 times 2x, which is going to be 6x, and remember it's going to be a negative because that 3 is negative, and then we're going to take negative 3 times positive 4, that's going to be negative 12. So negative 3 times positive 4, negative 12. Now, add like terms before we do anything. So on this side, on the left side of our equation, we have a positive 2x and a negative 3x. When we add those two together, we're going to get a negative 1x or just negative x. Either way is okay. And then we have minus 16 is greater than, so over here we have a positive 6, negative 12. So adding our like terms again, that's going to be negative 6 minus 6x. Okay. Again, if you need to, pause at any time, rewind, whatever you need to do so you can understand the concept better. Okay, now we're going to add our like terms, but on both sides. So first off, I'm going to add by 16 to both sides. And if you want, you could add by 6 to both sides. I'm just doing it this way so I get a positive number. So I'm left with just negative x or negative 1x on the left side of my equation is greater than, so those 16s are canceled, they are now gone, is greater than, so negative 6 plus 16 is going to be a positive 10, right? So we're just taking 16 minus 6, and then minus 6x. So add like terms, so add by 6 to both sides, add 6x to both sides, and we are left with 5x is greater than 10. Divide by 5 to both sides. Lucky us, it's going to be a positive number. We don't have to flip the sign. So our answer is going to be, I'm just going to draw an arrow up here for my answer, is x is greater than 2. There's my answer. I didn't divide by a negative, so I did not have to flip the sign. Okay, so that is example 2. Go ahead and look in your textbook, so page 533 with me. So that is what they also got. They also got x is greater than 2. But when you graph it on a number line, you guys know how to do that. It's going to be an open circle at 2 because it is greater than 2. It's not greater than or equal to. So you fill in the dot when it is or equal to. And then it's going to be all the values that are greater than 2. So it'll be 3, 4, 5, 6, 7, 8, 9, 10, all those numbers. It can even be 2.11111, but not 2. It does not include 2. Okay, so now we're going to move on to example 3, solving special cases. Solving special cases. So I'm going to get my board erased here. I'll give you guys a chance to catch up. All right, guys, let's go ahead and continue here. I'm going to do both letter A and B for example 3 because they're both different types of problems, but I am going to skip over example 4 and let you guys do that one on your own. So example 3, letter A, because example 4 is just the application. So letter A, we have some special cases here. So letter A, we have 3x plus 4 minus x is greater than 2x plus 7. So essentially what we're doing here is we are checking to see if our answer is correct. Okay, so what I mean by that is we're going to do the exact same process that we did in example 2, but now we're going to see if we were correct in our findings. So let me show you what I'm talking about here. Okay, so first things first, I'm going to subtract by 4 to both sides. And it doesn't matter if you subtract by 4. It doesn't matter if you combine your like terms first. Whatever you do, just make sure you do it in the correct order because it is all the same under the rules of PEMDAS. Okay, so I chose to subtract by 4 to both sides. We are left with 3x minus x, so my 4's are gone, is greater than 2x, and then positive 7 minus 4 is going to be positive 3. Okay, so add your like terms now. So I'm going to take 3x minus x. We have 2x is greater than 2x plus 3. Okay, so when I subtract by my 2x to both sides, you're going to notice something. My x's disappear. My positive 2x minus 2x is going to be 0. So 0 is greater than positive 3. Is that true? No, it is not. So not true. So you can say, I'm okay with you saying not true like this, or you can just take a big circle around your answer and and then cross it out like that. So same type of concept. That's just saying that this inequality is not true. Because is 0 greater than 3? No. 0 is less than 3. Okay, so let's go ahead and try letter B now and see if letter B is true. Okay, so I'm gonna erase all this stuff here. Okay, so letter B, we have 3 times 2y, 3 times 2y minus 6 is less than or equal to 6y plus 4. So for this process, we are going to do the exact same steps as the last example. So we're going to take 3 times 2y, which is going to be 6y, and then 3 times negative 6, which is going to be negative 18, which is less than or equal to 6y plus 4. Okay, so after you do that step, then we're going to do the same thing that we've been doing over and over again. So add our like terms. I'm going to add 18 to both sides. Add 18 to both sides. So add it to our 4 because they are the same, they have the same exact inequality. They have no inequality. So when we do that, our 18s disappear. And then you're going to take 6y is less than or equal to 6y plus 22. Okay, so our last step, subtract by 6y to both sides. You're going to notice that you have 0 is less than or equal to positive 22, which is true. So this statement is true. So 0 is less than or equal to 22. You could write true, you could put a check mark, whatever you want to do to say, to indicate that this statement is true. Okay? So that's all I have for you guys for this lesson. So once you are done with this, go ahead and get started on your lesson practice. So A through E. So you're going to skip over letter F because we're not going to do the application part of this. I don't want to get too much into it, but if you would like to, you can look through that, take notes on it, and try it on your own. Okay? Give yourself a little extra practice. All right, that's all I have for you guys. Stay safe and have a good time away from school. Bye, guys.